to myself. All right. Well, thank you to everyone for having me. And a lot of you already know me. So my name is Riaz Qureshi. I'm an assistant professor at University of Colorado on the Anschutz Medical Campus. My primary appointment's in the Department of Ophthalmology because I do a lot of work with Cochrane Eyes and Vision. I'm not an ophthalmologist. I'm an epidemiologist graduating from this program, Department of Epidemiology at Johns Hopkins and the Center for Clinical Trials and Evidence Synthesis. That was my home track. So today I'm going to present on something that's on a lot of minds over the last couple of years, and especially since 2023 when OpenAI released ChatGPT 3.0 to the public. It's hard to believe that was only last year. But this talk is mostly going to be qualitative and a mixture of my own experiences and thoughts, alongside some relevant evidence. The underlying theme is that I think we definitely need more research and guidance. A lot of research is still coming out in small scale case studies or case series, and we need more of these, and we need larger scale studies and prospective studies to help us figure out how we can really use these tools in everyday reviews. So I'll start off just by noting, remember again, I am with Cochrane, which I always feel is worth mentioning in a talk of evidence synthesis. And I'll also note that since 2020, I've been a consultant with Pico Portal on different aspects of their platform. For those of you who don't know, it's an AI-assisted systematic review platform that you can use to complete your review, just like Covidence. But there are some things I think Pico Portal is really paving the way on when it comes to AI integration. And my involvement over the years with them has mostly been on suggestions for features and design from the systematic reviewer perspective. But working with them has really afforded me the ability to explore the boundaries of AI in reviews, including having access to a wealth of data that we've really only touched on so far, but we do have plans to explore with greater detail. So I mentioned this because of its AI association and because some of the things that I show in this talk will be from Pico Portal, from that relationship. So we all know the systematic review process. I'm not going to spend much time or any time really going over this. Suffice to say, it's expensive, human resource intensive, and takes far more time than expected every time you begin another one. There seems to be no real way to gauge that other than it's going to be longer than you think. So this means there are many systematic review tasks and places where AI could be incorporated. We just aren't really sure how well it performs yet in all the different ways it can be incorporated. And a big challenge for most large language models being used is that they're not perfectly deterministic. So it's hard to benchmark and ensure a consistent result will be achieved in every situation. However, with appropriate training sets and prompts, I definitely believe there is a potential for AI, particularly large language models, to be used in more than just screening applications. So here are a few of the more recent studies on applications of large language models, in particular for tasks related to systematic reviews. And these reveal some strengths and weaknesses and where more work is needed. Before also diving into the meat of my talk, I wanted to put this up as I've shown it before when presenting about this topic, and I think it's a good summary of what's to come. I asked ChatGPT what it thought its strengths and weaknesses were for evidence synthesis. I thought its self-reflection was interesting, and I agreed on all the points. So it knows, or more aptly, it's able to predict based on the literature that it has digested in its training, that it has its own capacity to interpret or work with language. And so LLMs are most useful in tasks involving language and large volumes of text. And I know literature is still expanding, but I do believe these are probably valid and the most likely fruitful and low-hanging fruit for AI, given its current capabilities. And then I also agree with its own suggested weaknesses. So these are predictive models, and they don't actually understand language. So they don't perfectly get nuances of things like making final decisions on assessing quality and biases or providing true interpretation of results. We may ask AI to find objective answers within text to help us reach conclusions about these things. For example, asking whether a trial describes the randomization process or asking whether the limitations of the study describe any potential biases. But I don't believe these systems are yet capable of discerning what exactly those objective responses might mean when contextualized to the setting of the study to classify the risk of bias or provide the implication of what a conclusion means for practice. I presented recently with Karen Robinson at a Pico Portal webinar on the current capabilities for data extraction, and she made some very good points, which I wanted to reiterate in this talk. So thank you to Karen for letting me take some contents from a couple of your slides. As we move forwards in exploring and integrating AI with our human systematic reviewing process, we should consider the potential gains and losses. So of course, we hope for a more efficient process and better speed and accuracy, maybe the ability to train the models to better suit our needs. And that gives us, hopefully in the end, additional time for syntheses. But with these models being somewhat of a black box, we do lose a good bit, I think, of the transparency that, as systematic reviewers, we really hold dear, and to our ability to reproducible research and transparent research. And even though we can increase our speed and hopefully accuracy, do we maybe have unrealistic expectations of that? And is there a risk of perpetuating biases within the literature? And then there's also potential for a disconnect from the evidence, which I'll come back to near the end. So in this talk, I'm going to move pretty quickly through, I think, all of the systematic review process and where I think the current capabilities and limitations of AI and LLMs are in relation to systematic reviewing. Hopefully this will be interesting and perhaps enlightening for some, and hopefully also ease concerns about AI taking over our jobs for others. I don't think it's there yet. So the first area, oh, I skipped this. As we go through this talk as well, I'd like everybody to keep sort of these questions in the back of your mind. This also came from Karen, and I think these are excellent primers for discussion and thinking about the way forward for AI integration. So what do you need to see to trust the AI results? What's the biggest concern, and how do we evaluate AI? What is the appropriate comparison when we are, evaluating AI, and what are the best practices for our selection, use of, and reporting of AI? So I think the first area where LLMs can have some utility is actually in helping getting started with drafting of the review protocol itself. So aside from the background, most protocols follow a very structured setup, especially when they're in a structured environment like RevMan. Review Manager is the program used by Cochrane to write their reviews. And even outside of RevMan and Cochrane reviews, there's only so many different ways you can write how you'll do the search, how you'll extract data, how you'll set up your analyses. So we all know the patterns and what to expect when we begin to write out a methods section. So because protocols can be quite formulaic, I think there's untapped potential here in asking a large language model to get us started. As with all things related to large language models, what you get out will only be as good as what you put in or your prompt. So it does help to be an experienced reviewer and methodologist, because you can ask for specific things that will tailor your initial draft of your response to what you want. If I wanted to specify different databases or registries, for example, or add in different additional searching methods, it's easy to put those into the prompt. Note that I have also put the model and when the prompt was run on the slide. So given the pace at which LLMs are progressing and the differences between them, being transparent in your use is absolutely necessary. These slides, also I'm not going to apologize for having a lot on the slides because I was told to never do that. But I will say it's necessary because of that transparency. I want to put the full prompts that I'm putting in, and I want to put the full results that I'm getting it back. So that 2 minutes of writing, that prompt has produced some text that fills all of the initial requirements for me to edit and clean up as needed. And here's the strength of the LLM and what it clues into. So it interpreted that I asked for methods for a systematic review. And you can see that I specified initially the databases and working with a librarian. But as expanding additional context and content, you can see it's added lines about tailoring search strategies to different databases and making the strings with appropriate keywords and medical subject headings, which I hadn't told it to include. So it interpreted what I needed, and it gave me more than what I asked for, which can be a good thing and also can be a bad thing. An example of a task that was harder for this system is generating a search strategy. And this is something I do think should be left almost completely to the librarian or informationist, unless investigators have extensive training in the area. And even then, I think it should still involve a librarian at some point. But it is a question that a lot of people wonder, because if you could tell an AI to run a good search automatically, that would be a huge help in getting started on a review. So we asked a fairly complicated question back in 2023, the first time we looked at this, and the response looked at face value like it was okay. So there are clearly marked mesh terms and keywords that'll be searched in all fields. There's Boolean operators combining terms within a concept. It did correctly interpret that we have sort of three different concepts to search for. And it's got ors and ands in there. So it seemed like it understood. But if you run this search, you only get 34 results. And at a more cursory glance, there are some glaring issues with the response. So because it's a predictive model and it doesn't actually have access to the mesh database and structure, it's hallucinated mesh terms that don't exist, or it's put entry terms as mesh terms. And it's also created a filter for a study typed, which was unprompted, but also incorrect. So this is an area where the ability of the system to learn and develop with the user's input, I think, is useful. Because if you tell it to use a specific trial filter and provide the string, it will replace the code. If you tell it that several mesh terms are incorrect and provide the relevant terms, it'll update that and make the corrections. So through an iterative process, what starts as a poor search, it can be made better. And that search, it was the first time trying this. I did run it again in preparing for this talk to see if it was any better. And the search was definitely a better starting point, and it didn't include any fake mesh terms. I'm not sure if they've actually been able to integrate the mesh database. That's probably some plugin out there where you could be more specific with that, but this was just based ChatGPT for. And so I think it's still an area that could be tested empirically and quite easily probably to see how sensitive an AI search strategy might be with existing completed review questions and included articles. If anybody's interested in doing that, reach out to me and we can talk. So another drafting section, the methods for data extraction. This is pretty formulaic. We generally use two independent extractors, and all we really need to tell the LLM is which program we'll be using, how to resolve discrepancies, and which risk of bias tool is appropriate. And now it's taken that and given us a nice start to the description, including, again, unprompted, some common data extraction items, and these can be expanded and if tailored to fit your review. It recognized the risk of bias 2.0 and put in some extra information there about the domains and overall rankings. So this is, I think, a great start to the section. It's gotten us, in 2 minutes, less than 2 minutes, probably 75% of the way there for these paragraphs. Last example for the methods, the analysis, it's a bit more specific to the review and less formulaic than other sections of the methods. But LLMs could be useful for getting started, as we can tell the program to give us a start on how we want to assess different aspects of heterogeneity, what kinds of analyses we might do for certain types of outcomes. So I've told it, to describe the process of checking clinical, methodological, and statistical heterogeneity, but I haven't said anything about how that should happen. And the text that it gives us to work off of, it clearly describes how we can begin that qualitative synthesis, a generally accurate assessment, I think, of clinical, methodological, and statistical heterogeneity. And even more than that, as well as how we might conduct our analyses. So there's also some standard language for sensitivity and subgroup analyses, which I didn't ask for. And this is one point where I think some of those additional things can be problematic potentially. So criticism can and should certainly be drawn about the output. Because these are predictive models, it brings up that one point from earlier that Karen mentioned about the risk of perpetuating biases. So these are built on lots of literature, and things that are in the literature, common practices, whether they're good or bad, will invariably find their way into these kinds of output from these models. So we know we shouldn't select the type of model based solely on the heterogeneity, for example. And there's two ways around this. You can be more explicit in your guidance when writing your prompt, how you want it to do specific aspects, or more importantly, you should, of course, be carefully examining and editing the text that you receive in response to the prompt when it comes to writing. You should never just take what you receive and just paste that as your own language. That's not appropriate. And you don't know if it maybe hallucinated something or said something that's incorrect. So moving on from the protocol and writing, it's worth mentioning the AI-assisted screening, as this is one area where we have good evidence already in terms of machine learning, but still need more in terms of large language models. So there's already a substantial integration in AI-assisted screening with machine learning. And the setting of review, where you have thousands of records that are really just yes or no, is perfect because two independent reviewers screen and reach final decisions about inclusion or exclusion, and that creates a training set for the remaining records, which the AI reorders based on its predictions. So by this point, we know this helps screeners get through the total number of records faster. We can see with this data that we took from Pico Portal for 8 systematic review projects that had completed with double independent screening, that random screening, X equals Y, is what we'd expect. And then what we actually saw with the AI-assisted screening is sort of this more of a curve, time and time again, of reviews where you capture much more, your recall is higher on your Y-axis, with fewer records screened than expected. So in random selection, when you screen 20% of records, you expect to have captured 20% of your included articles. To capture 100% of relevant records in expectation, you need to screen 100% of your records. But with machine learning reordering, if I took the weighted average of those 8 projects, we've got a closer pattern of capturing around 80% of relevant records after 20-25% being screened, and around 95% of the records captured by the time 50% of records have been screened. This pattern has been replicated by others, just as one other example, here from Lisa Wilson and Karen Robinson, also from Hopkins. This was presented at GES this year. So we know this works, and we know that AI can help to screen for relevant articles much faster than random screening or sorting by author name or title. And it does depend a little bit, of course, on the project. If you have a review that is focused on a single drug and randomized controlled trials, that's much easier for a machine to figure out what it is you're looking for in the titles and abstracts than if your review is a complicated, multifaceted behavioral intervention and multiple different study types. So you will need to screen more to find relevant records for that. But in all cases, it is less than we'd expect by just sorting, how Covidence used to sort. And Covidence even now has adopted this, although it was late to the game and it only brought this into its system in December 2022. So these data, of course, they're great to see after the fact, but hindsight's 2020. So how do we know the model's working as we're screening and when to stop, or if we should stop at all? A tool should really give the user some estimate of how well its predictions are working, and while screening is actively going on. And this could be from the true positive, true negative, false positive, false negatives, based on the machine predictions compared with double independent screeners. So this allows the user to estimate positive and negative predictive values, which can be applied to remaining records to see how many might remain unscreened and still need to be screened. So after the review, then, if the human screened 100% of records, these metrics can also be used to calculate sensitivity specificity of the models. And it's worth asking whether one should stop completely at some point, or if it makes sense to switch to a single reviewer. That would be a safer way, and it would still cut the resources in half past a certain point. If it makes sense to stop or switch, I think the key thing is that you have to be transparent about that. You have to pre-specify when and how you're going to stop or switch, and if you are. So one sort of rule that I like to use some variation of depending on the question and complexity of it, but I think if the machine predicts we've captured at least 95% of the relevant articles with a negative predictive value of at least 98 to 99%, that essentially guarantees ruling out the remaining studies that it doesn't think we've captured. And there are also novel statistical methods being developed that will help reviewers stop with more confidence and consistency. Just to note that sort of, ideal of transparent, or as transparent as they can get, with some of these models, the way they're built. The predictions, that true positive, false positive, true negative, false negative, those predictions are something that Pico Portal gives everyone using the project, and I think it should be the standard. Once the machine learning kicks in, the system begins giving metrics on how many records it thinks you need to screen to reach a certain level of recall, and then based on its own predictions of records and how the two humans have screened in their final decisions, it also tells you its sort of accuracy of those predictions that it was making on those records. So this doesn't, it doesn't make any decisions for you in terms of whether something is included or excluded. It just reorders, but this is a good transparency to have. Of course, we know machine learning can help us screen faster. But what about large language models? Those are two different pools of AI that people are talking about, two different sort of ways to approach it. And there's still more uncertainty here about how good LLMs are at screening untrained. In theory, right, they're good at contextualizing language and interpreting language. If we give it a set of eligibility criteria, we should be able to ask it to specify relevant records from a set based on titles and abstracts or full texts. We've met with mixed success with this, testing this on our own. Again, probably the complexity of projects really impacts that ability. And this paper also found pretty wide-ranging results. But I think this is a good point that speaks to the overarching theme of AI assistance rather than completely AI. And in my view, I don't think it actually matters that much if LLMs are really good at pulling all the relevant records, if their sensitivity is not that great. I think if we're able to take a set of 10,000 titles and abstracts and give eligibility criteria to a large language model, and it spits back for the 500 most likely relevant ones, even if the sensitivity is as low as 50%, that means you could expect at least half of your includes overall in a fraction of the time, in a couple hours of screening those 500. And combining that with the machine learning that we already know works well, that's given you a much better set, a training data set for the machine learning, so that after those 500, the machine learning kicks in and pulls any remaining includes likely to the front of the line. So I think there is value here, even if it's not perfect. So we've done our screening now. What's the utility for actually getting us started and extracting the data so we can begin our synthesis? There are two facets to this. One, of course, risk of bias, and the other, data extraction. So both of these have some small scale studies that generally find it performs reasonably well. I think that's the best broad conclusion I can make. Authors here in this review of the study concluded both models had demonstrated substantial accuracy and consistency, suggesting their potential as supportive tools for systematic review processes. And to bring back an earlier point, and one of ChatGPT's self-appointed limitations, I don't think it's yet really that great at determining whether a particular passage conceptually and contextually places a trial at high or low risk of bias. But I think there's a really good case and likely strength in picking out and presenting sections of text to the reviewer that are likely to give the answer, and then having humans make decisions based on those, essentially using the AI to identify the justifications to support risk of bias assessments. For data extraction, this was another paper that looked at that sort of with another large language model. And Claude 2 demonstrated an overall accuracy of 96%, making a few data extraction errors, also concluding that LLMs had the potential to substantially enhance the efficiency and accuracy of data extraction for evidence synthesis. So these are both of these, all of these studies are not finding that it's perfect. They're not finding that it should be left to its own, completely owned devices. But I think there's a case to be made for its use as maybe the initial reviewer, and then having somebody go in and verify all of that. Tianjing and Ian, others at our center as well, actually, they ran a randomized trial to show that Single extraction with verification was just as good in some cases, depending on the complexity of the question, as double independent data extraction, which is still the general standard. So maybe there's a case to be made for having AI be that single initial extractor. I think I'm good on time here, so I want to take just a few minutes, 5-ish, to demo what that AI-assisted risk of bias and data extraction looks like in Pico Portal. As I said at the start of the talk, I think they've built this in a smart way that can help humans complete both tasks with some assistance. So in the randomization and in the risk of bias assessment, you've got your form questions on the left, your main form here. You have AI suggestions on the right. This first, risk of bias 1.1, is the study randomized? If you click on the question, it generates the PDF with what it thinks is the most likely relevant text highlighted for you. And you can see here, just scrolling to find a highlighted text, instantly we've got our justification. Yes, it's randomized. Okay. Moving on then to 1.2, we can sort of already see here, because we're experts, we know the material and where it's sort of located in papers, but to somebody who's not as trained, maybe this is helpful in them in figuring out where to look for these kinds of things. Here we know this, we would pull this and answer the next question right away, but pretending we're somebody less experienced, let's instead click on 1.2 and see what the AI has highlighted. Hopefully so it's highlighted that section as being the relevant section of text to provide a justification for allocation concealment. And then let's also look at 1.3 baseline differences. Again, we've got a fresh PDF with new highlights, nothing in the methods as expected. We'd look to the results. We don't have that description of baseline characteristics there, but here we've got it. Baseline characteristics were similar between the groups. The only parameter was a significant difference between a somewhat longer duration of surgery. So you could then, as the human, make that decision if that's enough to say if they were different or not. But it's highlighted relevant text. It's helped us reach those decisions at a faster rate. So I'm going to close the risk of bias and switch over to data extraction, because I think it's got one interesting example as well. So scrolling through here, if we say, something that we're hoping for something verbatim, inclusion criteria, we want to copy and paste from the methods. We've got this text, and we can check that, again, so highlighted up here, we're aiming to investigate this. It's kind of relevant, but it's not the inclusion criteria. Here we go. Here we've got our eligibility criteria, inclusion, exclusion, and they are word for word taken out of the text for inclusion and exclusion for the next question. Something that's a little bit more results oriented. Let's take a look at the sample size. So what was the total number that was randomized? It's given us 260. And if we scroll to the start of the results, we can see 260 participants were included and randomized, 132 PRM and 132 control. So we've got 260. Number randomized to intervention, we've got 122. Where's that coming from? That's not what it says in the text for that were the number that were randomized. And actually 122 doesn't appear anywhere in the text. 122 appears in the table because 130 were randomized, but 8 never received it. 122 received the intervention that were randomized. And then likewise for the control, 126, it says were randomized to receive control. There were 130, but 4 of them never received it. So there could be some argument made here about which is correct. And I think it probably depends on how you want to, as the reviewer, how you want to answer that question. I think this is an example of a question where you'd probably have discrepancies between the human assessors as well. But it shows something interesting in that the AI has interpreted what we asked for, and this is maybe in the prompt somewhere, but it's interpreted as how many people got the control, basically, how many people got the intervention, in which case it's correct in 122 and 126. It's also interesting that it's pulled that from a figure and not from the text. We also see that it works with tables and things, so asking it to pull the sort of overall age for the intervention and control, and that's nowhere in the text. I know this paper that's here in the table one. So that's just to show how I think AI assistance can be integrated to help people get through data extraction risk of bias faster, but not taking it over completely. Moving on, and I just also, this is another point here. So it's worth noting the LLMs, they're also useful in their base interface. So Pico Portal has it nicely set up to flow along with your data extraction form. But I wrote this prompt as an example to create a table of study characteristics based on the abstract methods and results text that I fed into GPT-5 trials. I explained how I wanted the table set up, how I wanted the characteristics extracted. And 2 minutes later, I had this full table of characteristics. I ran this in Scholar GPT, which is a plugin built on native GPT 4.0. So the result was a full table of study characteristics. And, this looks good. How accurate is it? Study ID, intervention, comparator, follow-up, conclusions were all spot on. Interestingly, the quotations were not all accurate, except for the direct extracts from the abstract conclusions. So not sure why it, gave me quotes when I only asked for quotes specifically on verbatim sections, which it didn't give me verbatim. So that's why the eligibility criteria are in red. They're correct, but they're paraphrased. And they're not verbatim like I asked for. So that's something where tweaking the prompt could probably give it to better, or use this as a starting point and build off of it, find the eligibility criteria and copy and paste them into the table yourself. Synthesizing the evidence. Now we've got our data extracted, our risk of bias as well. We're starting to get into our results. So where's the potential to help us here? So beyond the methods, there are also some aspects of the results that can be pretty standard. Describing a search, is one paragraph that never takes long to write. But just for a proof of concept, I asked for a summary and imported this image. So imported, again, working from an image just into ChatGPT, and it put together the following text. What's interesting is I think it actually made some inferences as the flow diagram that didn't provide the total number of records. So if you look back at this, we've got records identified through database search and additional records, and then records after duplicates removed. But it didn't tell us the total number of records or how many duplicates were removed. But it was able to do that math for us and correctly sort of infer that total we had 2,217, and after removing duplicates, that gave us 2,202 that remained for the screening. So this text could be edited into a paragraph, but this is just how the program presented it as bullet points. In terms of actual synthesis and starting to digest the information, can LLMs help us with this? So near the beginning, I highlighted some considerations from Karen, and one that stuck out is losing the connection with the literature. When we do a review, we immerse ourselves in the included studies to really evaluate them. And I do think it's true that if we're able to automate or get assistance with most aspects of getting to this point, it's likely we'll have a more shallow understanding of what we may have to work with. However, it's also true being able to reach this point quicker and more efficiently would give us more time to devote to synthesis. So for this task, since prompts are really, really important, I clearly noted how I wanted the group separated based on time, which is an important component for outcomes, and to include any point estimates where available. So the system correctly grouped these studies as I requested, and the statements concerning the specified outcome were all correct based on the data that was given to Scholar GPT. A few of these studies did have quantitative estimates for blood pressure in the tables, but they didn't mention these estimates in the text. So, this is an example where I think I'm glad it didn't make up data to fill in the spots, because that is something you do still have to worry about. And that's why you check. You check over to see what it's given you, and use it as a starting point, maybe. Similarly, at the longer time point, study evidence was correctly summarized, and the summary appropriately suggests the evidence is inconsistent and limited, and may not be clinically significant across different populations. So I judge this to be a fair summary given the evidence, and not a bad starting point for describing the overall evidence that you might have for an outcome in a review. Second last thing here. So I know there are ongoing and recent studies to evaluate GPT's ability to help with writing. I also wanted to present if it could help communicate a complex summary in simpler language. So I took one of the Cochrane reviews that I had written with Tanjing, and Cochrane reviews, their main abstracts are written quite high level. I wanted to get it down to sort of a plain language summary. So the revision is on the right. It did take 2 tries because the first time it still gave me back a 10th grade reading level, and I wanted it even lower. But it took 335 words, brought it down to 251, and from a 12th grade reading level to an 8th grade reading level. And in my opinion, my perspective, the revised summary still presents the same overall conclusions, minus some specific numbers. And it is more accessible, I think, to the public. So the opportunities, I think, here extend beyond revising for reading level, but also for authors whom English is not their first language. That could potentially have some use. And then the last thing I want to show is some data that I had from a case series I did with Michelle Karras here at Hopkins, or used to be at least, on summarizing whole studies for the purpose of creating annotated bibliographies. It's not exactly a systematic review task, but it is useful in the broader concept of literature and reviewing. And, we're always, when we start a review on a new topic, we've got to do a lot of digging to sort of get ourselves immersed in the area. And so annotated bibliographies are a useful way to, create little summaries of the papers, the lots of papers that you have. And here we had 2 human annotators and 4 different AIs. And we judged the annotations based on sort of word count, reading level, whether the annotation captured the main points of the article, presence of errors, and the quality and the contextualization of the summary for the paper. Overall, we found they were pretty comparable. Readability was better for the AI than the humans, but they were definitely more wordy in their summaries. And I think they were similar in terms of addressing the main points and the amount of errors. The AI provided context more often than the human annotations, which I think that's one of the strengths, the abilities that it has, because it's got such a large training set. You can ask it a question about an area and it can spit back something about generally what you might find in the literature about that topic. It might not be good at giving you exact references. Sometimes some plugins are getting better at that than others. But it can give you a sense of what you might find. And so that kind of contextualization is hard for a human who doesn't know the area, and when they're reading a paper for the first time, but an AI could give you that. So I think it's fair to say use of AI in systematic review tasks will very quickly become the standard as a way to do things faster, but we still need human involvement. That's necessary in pretty much every aspect. The biggest thing for us to determine still is how exactly to report and be transparent in the decisions. International Collaboration for Automation and Systematic Reviews, ICSR, they're one group of several that are looking at really trying to, how can we be more specific and explicit about these? I think this is really where we can focus our energy in trying to simultaneously, use these and integrate these tools into our human-based approach, to allow for better replicability and hopefully figure out how we can get better replicability, how we can benchmark to actually see, how are these working and can we reproduce them? And that'll help us to better assess the abilities overall. So that is the end of that, and 15 minutes left. Excellent.
Thanks, Riaz. I am not Ian. I'm Karen. Ian cannot connect. He's unable to connect, so I'll help moderate the questions. We have two questions in the chat, and then other people, if you want to raise your hand, that'd be great. Evan, do you want to ask your question? I see yours first in the chat.
Yeah, sure. Great summary, Riaz, and great overview of where we are. The Pico portal example, I think, is a good model for how we might do machine-assisted judgments and things. But you didn't say what was happening in the background, and I wonder if you could talk about how they're doing that. Are they using a fine-tuned model? Are they processing the PDFs and prompting GPT to answer questions? What's happening behind the scenes there?
So it's a great question. The way they've built theirs they do use GPT and they use one other one, and then they have their own way of identifying the text. The GPT is really used in terms of generating text, so that's what they use for creating sort of the responses that you get out of it, because that's sort of the large language model. The other system that they use, I think they have their own proprietary system as well, and for determining which sections of text are most relevant. Essentially, they read in the PDF and then assign sort of scores to the text, and then based on the question that gets asked, it sort of spits back what are the most likely relevant ones. But they have a specific way of doing it, and I don't know that I can explain it perfectly, or if I could also, I'm not sure if, yeah, that's all right.
Okay, so it's secret.
GPT is what it's built, what it uses for producing things, but it's the system they have designed it to sort of be agnostic, and that if there was a better large language model, they could switch it over to that, and the system would perform better in theory.
Ahmed?
Hi, so I have two questions. So we have been actually hosting language models, and we have been tuning them here at Johns Hopkins, and we have been using them for systematic reviews and screening. And then we noticed the vanilla models, most of them were hovering about the 70% accuracy. But then when we used different prompting language, we no longer deal with the AI as using the same way we request a prompt from a human. We rather change the way we prompt the machine to almost talking to a child. We reached 99% accuracy in the screening and data extraction. And we found that the screening substantially, significantly improved by not asking the AI model to classify, but rather asking the AI model to extract the ingredient for the classification, and then use a decision model to do the classification. That substantially improved the accuracy and the positive predictive value and negative predictive value. So I was wondering if there is any of that in the background of Pico. And the other one is GPT-4, while it's relatively new, when we did a clinical reasoning testing for it, it performed miserably. But then when we tested for Preview, the new one, the reasoning model, it excels substantially. So, and it was just recently released. And the performance is day and night between them when it comes to clinical question and clinical reasonings and even in public health. So how Pico will maintain up-to-date models if like can they update their 4.0 to the 1.0 preview, or will they stay with 4.0 for a while and then they will update the model? Because OpenAI keep pushing the models much faster, and 4.5 is coming before the end of this year also, which is much better than what we have right now.
Yeah, great questions. Just had to plug in there, sorry. So to answer the second one, yes, they can switch over. As once an update comes out, you know, it's just a click of a button to switch over which one it's using for producing the output. In terms of the prompts, you're absolutely right. You know, the prompts matter so much. And you know, Evan and I we've gone through an experience with this and trying to, you know, write a pretty detailed prompt with a team of people on, you know, classifying outcomes, and that prompt is like 30 pages or something ridiculous. You know, it's you do have to talk to it like a child, and that does help in getting a response, I think. Right now, the prompts in Pico Portal, our user input. You know, Pico Portal doesn't control the prompts or influence them. You as the user, when you build your data extraction form for each question that you have in your data extraction form, you can turn on AI if you want, or not turn it on. You can leave it off. If you do turn it on, it'll generate an automatic prompt for you using GPT. Sort of takes, you know, what your question is and then spits out what a prompt might be. But I like to make my prompts personally. And so you can edit it, and you should edit it to make it better, I think.
Yeah, Ahmed, in terms of screening, my understanding is the current system, although it keeps changing, it feels like, is using 3 different layers or models of NLP and machine learning. So it's not reliant on one particular prompt or one particular version of GPT.
Okay.
Elizabeth?
Hi, yes. Thank you so much for speaking. A fabulous presentation. I really appreciate the idea of like the AI being able to dissect papers, but I've been thinking about what it would look like to have a more formulaic response. I guess more scientists can now use large language models to write their own result section. And would it be helpful to for example, go through and maybe write reports in a way that are more accessible to AI for the purposes of systematic review, instead of having the AI go through and check the boxes, yes, no, is it randomized, is it allocated properly? Just doing that from the forefront as the scientist for the purposes of systematic review. Can you speak on what you think that would do, or what that might look like?
Yeah, it's a great question. And you know, I think there's a case to be made for it. What we lose, I think, is interesting papers. You know, people have a writing style, and you know, being able to write free form makes reading papers enjoyable. Of course, that can carry with it all kinds of difficulties when you're looking for something specific that isn't where it should be. There's already so in the journal Trials, we publish a lot of protocols. We now have, as of 2 years ago, and now we sort of encourage it more and more. Authors submit their protocols using a structured template. And this is essentially that exact idea. Instead of a free-form protocol where authors, you know, write out a flowy, nicely written manuscript that dictates how their trial is doing, this is essentially just spirit item 1, 2, 3, you know, in an order that makes sense for the flow still, but it is structured and it has the headings, and authors fill it out, and it makes it so much easier as a reviewer to check and see that they've included everything you need to understand what they're doing in the trial, as well as the reader then, when it gets published, to, you know, find exactly that. What was it that they did in the trial, and transparency. So I think there could be a place for that in certain areas of science, but I would hate to also lose, the maybe papers can be structured and nicely laid out for the results like that, but you still allow people to write their introduction, introduction and discussion with however they want to. That would be maybe a compromise.
Yeah, I think part of what's tied up in your question, I think, is the need, and what a lot of people are working on right now, on interoperability. So developing systems to use EBM on Fire, JSON, using languages and standard terms, so that there can be free-flowing information between systems, whether you're wanting to use AI or whether you're wanting to update a review or use the review data for a guideline. I think that's a very related movement, this interoperability as well.
Thank
Yeah.
Thank you. Just like as a follow-up, would it be helpful then to have, when you're submitting a paper, maybe you keep the introduction and discussion, or keep all of the language you want, but then simultaneously require the original authors to go through and categorize their own, like their own PICO requirements, to make sure that it can be then imported to something that can be readable by these AI models?
Like classify each sentence or a paragraph to a certain area. That could be
Or
something.
even answer the questions like, is it randomized? Is it blinded?
Yeah.
I guess that would maybe bias the results, but presumably it would be easier for the AI to read and with more accuracy.
Yeah, it's something that could be considered. I think you'd have a hard sell on journals making that a requirement. And if it's not a requirement, authors aren't going to do it for the most part. But they're to the point of like the reporting and stuff. At least that's hopefully what sort of the reporting guidelines for different article study types and things have tried to do, right? And including a consort checklist, including a Prisma checklist, including a Moose checklist, whatever. It helps a little bit, but they're not always accurate. And even then, you still have to find the page and read through it and figure out if it's there. So, yeah.
Thank you so much.
Yeah, and Elizabeth and others, I just put in the chat a link to Fever platform, in which you can find information about HEVCA, which is a group working on interoperability. If you want to know more, learn more about that.
I also wanted to address Kay's question. You care about how much electricity AI uses, and it is a fair question that I think a lot of people raise when talking about the resource cost. It reduces human resources, but is there an environmental impact? And I think for some scale of things, there absolutely is. Like ChatGPT, OpenAI, their system, as with all the requests are coming in from everywhere and everything, it does take up a huge amount of power and energy. I think on the individual systematic review case, it's probably not that much. And if you were to sort of try and do, I don't know how you would set up an energy comparison, but if you could sort of compare, what you would need to really do, I guess, is the energy consumption for pulling that kind of stuff from a paper on the AI side, and then the human equivalent, how much computer time would a human need to review and come up with, and in terms of the time saved that the human has and what the AI needed to get that kind of answer, you would need that kind of comparison to see if it is cost beneficial or not, if it's effective. I think there's a case to be made for reducing the energy use as much as possible, and to that end, You know, I don't think the AI should necessarily be used to, you know, find everything, all of those data extraction, risk of bias assessments on every full text that you have. You know, I would say limit it to, you know, the ones that are included as one example, instead of having it just run everything all the time. Try and limit when it's run and on what it's run. And so we can still be responsible about the use, even if, you know, even if we're able to make a direct comparison and show that it, you know, it's less resource intensive overall.
I'm very sorry, I need to run to my next meeting, but this is very interesting, Riaz. I don't know if people can stay on and continue to chat. But I need to run. Thanks, Riaz. Nice to see you.
Thanks, Karen. Okay, I don't know if you wanted to say anything. Oh, you're muted.
Sorry. You gave the right answer. You're going to try and compare it to humans and how much effort that takes.
Yeah. Ahmed.
Yeah, so I have a question about the IP, because we were having an issue about the IP within Johns Hopkins. For example, we are currently using an offline LLM, so it's not connected to the internet and it's completely within our server, so there is no leak of data to any of the companies. But if we use the Microsoft OpenAI implementation, which we have a contract with at Johns Hopkins, there is a long term of condition language that even though we have access to those literature and studies, we cannot expose it to the OpenAI model because we may violate some of the IPs for some of the journals. So if I use Pico and then I will have a list of articles that I'm screening through Pico, then OpenAI will technically get a preview of those articles and get access to the data. From a Johns Hopkins point of view, where we may be at risk of violating some of the IPs for some of the journals. So how Pico is handling that? Because that has been a major hindering factor for us in using company's LLM rather than our offline LLM.
That's you know, it's an interesting question, and I don't have the right answer for it. I don't know all of the inner workings of Pico Portal. As I sort of said in the start, I'm really just more of the consulting I do is mostly on sort of the features and stuff. And then I get to play around with the AI because of that. But please do send me an email.
Okay.
I'll put the email again in the chat. Anybody can send me an email, but you especially about that, because I'd like to discuss that further with you, and maybe bring on A10 Pico Portal as well.
Yeah, that would be great. Thank you.
There's my email.
Well, thank you. We've really appreciated your time here and lots of interesting things to think about. If there are no more questions, and even if there are and you'd like to continue with your day, thank you everyone for joining us.
Thank you all for having me.